Moving on with lesson 3.9, example 8. The altitude of a triangle is increasing at a rate of 3 centimeters per minute, while the area of the triangle is increasing at a rate of 7 centimeters squared per minute. At what rate is the base of the triangle changing when the altitude is 15 centimeters, the area is 150 centimeters squared? So, looking at things that are changing. The altitude, which is the height of the triangle, is increasing. The area of the triangle is increasing, and the base of the triangle is changing. We don't know if it's increasing or decreasing based on what they're telling us. But so there's three things changing. So you got this base that's either shrinking or getting bigger. You got the altitude getting bigger. The area altogether is getting bigger. We have to determine all this stuff going on. So if we start off with just some generic triangle, it doesn't matter what it looks like. I'm going to take I think an isosceles triangle is easier to work with. So let's do that. It doesn't have to be isosceles, but just some triangle. Now, the things that are changing are the area. So the area is increasing, so it's growing. I don't know in what way, shape, or form, but we can imagine that the triangle itself is getting bigger in area. The altitude is the perpendicular height to the base. So if I draw an altitude in right here, that's perpendicular to the base like so. And I'm going to use the letter H for altitude, just so I can use the letter A for area. So the height of the triangle is H. That's changing, so I'm using the letter H to represent it, even though they tell me specifically what H equals. That's where I come over here and put H equals 15 centimeters. Again, hopefully you're getting accustomed to this in your homework and your practice, that every time you draw a picture, what goes on that picture that's changing is a letter, and the letters are established with specific values over here. Okay, so H is changing. We're going to use a letter to represent it. The other thing I know about this triangle is it has some base. I'm going to use B for base. That's also changing because it says at what rate is the base of the triangle changing. So B is equal to something. And the other thing I know that's changing out of this triangle is the area. So they gave me a dH over dt. They gave me a dA over dt. And they're asking me for dB over dt, which is possible because I've got two rates given. I can find a third rate. So I can use three variables in this problem. Looking at our dH and dA over dt, we can see that dH over dt is 3 centimeters per minute. It's increasing, which is a positive 3 centimeters per minute. dA over dt is increasing, so it's positive 7 centimeters squared per minute. And we're looking for the change in base with respect to time, which is going to equal something. What do you think the unit on that's going to be? We got two different units going on here. We're going to get centimeters per minute. So the base will be measured in centimeters, right, where the area is measured in centimeters squared, so that's why it's going to have a different top part. Centimeters per minute is what we're looking for. So that's our goal, is to find that. We also know the area is 150 centimeters squared. All right. So, looking at a triangle, and we're dealing with the area and the base and the height. Can anybody think of some formula you might have heard in back in the day in geometry classes or other math classes that relates the area of a triangle to its base and height? Base times height divided by 2, or half base height equals area, right? So our relating equation is area is equal to 1/2 times base times height. And just like that, there's an equation that relates our three variables in this problem very well. And using that formula with the assumption that B is probably going to stick around, seeing that B is part of a product, right? So B is probably going to stick around in the process. So we got to figure out what B equals. If I put 150 in for A, let's try that again. 150 equals 1/2 B times 15. That means 300 is equal to 15B. If I multiply both sides by 2 to get rid of the fraction, that means B is equal to 20. So the exact moment in time they care about, the height of 15 centimeters, the area of 150 square centimeters, the base of this triangle should be 20 centimeters. And just like that, I have a relating equation. I have a whole bunch of information about the variables in the relating equation with only one thing missing, which is the rate I'm looking for. Again, that's your goal every time in these problems, to set everything up to get to that point where something relates to all the variables you're going to use. You know everything about the variables and everything about the rates except for the one thing you're looking for. When you get to that point, now you're ready to do calculus. One thing I'm going to do on this problem, not that us calculus students can't handle this, but A is equal to 1/2 BH is accurate, right? 2A is equal to BH is equivalent. It has no fractions in it, so it might be a little easier to work with. You don't have to do that, but it's not that difficult to make it happen, and it makes the problem a little bit simpler to deal with. So, if I go ahead and differentiate this, so again, here's my relating equation. This is where I'm trying to get to, relating equation. So I'm trying to differentiate that. I've got two terms. I've got 2A, which is just a basic polynomial structure, right? 2A to the first, its derivative is 2, easy. BH is a product of letters, so I have to do the product rule. All right, so number times letter, simple. Letter times letter, product rule. All right, just make sure that we're making connections there. So the derivative of 2A is 2. I'm going to put a dA over dt because A is not t. When I do BH, it's 1d2 plus 2d1. So 1 function 1 is b. d2, the derivative of h is 1 dh over dt. Plus 2d1 is going to be h times the derivative of b, which is going to be 1 dv over dt. Slide that back up so we can see our box of information here. Looking at this, all this stuff, dA over dt is 3, b is 20, dh over dt is, dA over dt is 7, sorry. b is 20, dh over dt is 3, h is 15, dv over dt is what we're looking for. So everything in that equation is exactly what we need, so it's just a matter of substituting everything in. So 2 times 7 equals 20 times 1 doesn't matter, times dh over dt 3, plus h, which is 15, times 1 doesn't matter, dv over dt. Alright, all I have to do is solve for dv over dt. So 14 equals 60 plus 15 dv over dt. Move the 60 over here. We get negative 46 is equal to 15 dv over dt. Divide both sides by 15, we get dv over dt is equal to negative 46/15. The only numbers to divide 15 are 3 and 5. Neither 3 nor 5 divides 46, so it doesn't reduce at all. Negative 46/15 centimeters per minute would be my change in base. So looking at this picture again and visualizing what's happening here, the height's increasing while the base decreases. Overall, the area increases as that happens, and there's our answer. All right?
Is it okay if we put it in decimals?
Decimal form 3.07 maybe, yeah. I'd be okay with decimal form. I prefer a fraction, but decimals are fine. Just give me a couple decimal places if you do that.